in for 1 second. My name is Holly Bennett. Are you ready? Everyone ready? My name is Holly Bennett. I work for Glengarry Brickwork. We have a team. I sell stationery, and there's a guy, Ben Saffron, and Daryl Kegley, who do all accessories. We have teams for everything. Development team. There's we sell everything and everything behind the brand. So today, Ben Saffron sets us up. He was unable to make it today, so I'm just here to say hi again, because I just had lunch and learn here 2 weeks ago. But this is Matt from Kingspan, and Matt can take it over.
Thank you.
1 second, and if I could ask for everybody who is here, when this goes around, whether you have your AIA or not, if you can just put your right name in, that's mandatory for me with my time. Thank you.
Thank you, Holly. Everybody, want to give it up? Give it up. Come on. Come on. Come on. Thank you. Appreciate it. Thanks for doing today. Cool. What's up? I'm Matt. I am the local area rep for Kingspan Insulation. We are a vendor partner with Glengarry for rigid insulation products. We're going to talk a little bit about who we are off the bat, what we do, and how that could probably help you out in the future. And then we'll follow up with the AIA presentation after that. Sound cool? All right, let's get into it. All right, so first things first, has anybody ever heard of us? Yeah? On an insulated metal panel kind of vibe? Yeah, that's pretty much the only way I get appointments. So that is actually not who we are. We are a rigid insulation manufacturer, specifically extruded polystyrene is our bread and butter, but we also have a little bit more. Kingspan globally, I mean, they're the largest, I believe they're the largest, I want to say expanded polystyrene manufacturer in the world. We did something like 600 million board foot last year, something ridiculous. Here's a map. It basically just kind of dictates where our locations and offices are. We're based out of the UK, but over here in the North America, we have our plant over in Winchester, Virginia, where we manufacture the foam. So we're right in the area. It really helps us service it. And then we have our Atlanta corporate office. So that's pretty much it for North America. You know, when you do something like that, when you do a lot, and when you're kind of a leader as far as really in any kind of genre or any kind of business, you really need to set the example and set the tone. So back in 2011, we actually embarked on a net zero energy initiative that by 2020, all of our facilities globally would be net zero. That's obviously coming up quickly. Last I heard, we were, I want to say 75% of the way there here in the States, and then almost to 90 worldwide. So it actually looks like we're going to hit. Yeah. So this is an overhead view of our plant over in Pembridge. Back in 2011, when we went on that initiative, we installed these photovoltaic sunroof arrays. And then we also have a facility here that collects farm waste from around the area, turns it back into renewable sources of energy. The building itself, I think it's a World War II U.S. Air Force hangar that at one point was the largest metal spanning beam building in the world. So I like to say, even though we're out of the UK, we're still American made. All right, so let's talk about insulation. So has anybody heard of GreenGuard? Yes, awesome, cool, makes my job easier. So GreenGuard was an insulation manufacturer that got started back in the 80s. For anyone who was around then, you remember the old Big Mac clamshell boxes? Anybody? Yeah, we made those, that was us. So that's kind of where we got started in insulation, and then we started producing rigid fanfold siding underlayment, broke into the rigid extruded polystyrene board, and then got into some house wrap and some other stuff. I have to say that graph's a little outdated, the pie chart's outdated. We, probably about a year ago, really started flipping it. So at one point, we were probably 60-40 residential commercial, maybe even 70-30, and now we're basically turning it on its head to where we are pushing to be almost exclusively commercial. I'd say over the next few years, we're going to flip that to another 60-40 commercial, maybe 70-30. So that's really where our focus is, and that's what we're going to be talking about. Any questions so far? Cool. All right, so let's talk extruded board. All right, so I assume everybody's familiar with Dow Styrofoam and Owens Corning Foamular. Yes. I assume you are currently specifying one of those two? Awesome. This is, if you're not familiar with the board, it is pretty much the exact same thing. I've been told the chemistry is like 0.01% different. So it is a direct equivalent with an equivalent offering. To make it basically simple, just to recap, it's an R5 per inch. It's closed cell, so it doesn't have any kind of moisture ingress, and you can use it below grade, precast application, underneath the slab, foundation, pretty much anywhere you need to stick rigid foam and you don't want it to get wet. And then also a multifamily if you needed it for a water-resistant barrier, all that. And then below slab, probably more if you're doing like a warehouse and you needed a forklift to drive underneath it, that's when you put the 40 PSI underneath. And then for cold storage, you would use maybe 60. And then up on vegetative roof systems. I assume you guys do a decent amount of work down DC and in the area. Green roof's all the rage right now. Probably going to need some of that underneath there. So that's when you use your 40 on your green roof, and then on your rooftop paver systems is where you bring in the 60. All that makes sense. All that just more review than anything else, right? Okay. So that's okay. Again, any questions? Nah, they're never wrong. All right, so let's talk about some new stuff. All right, so this is a pretty simple, straightforward graph. As you go up your y-axis, your fire rating increases, and as you go across the x, your thermal rating increases. All the numbers you're going to see are going to be on assumed 2-inch thickness. All right, so just to kick it off. So you have expanded polystyrene, basically whatever your coffee cup is made out of. Down at the bottom is an R8 at 2 inches, so not great. And then you have your fire rating, which is Class A. Like, I'm not going to lie, it's definitely Class A, but it is like bottom of the barrel Class A, just barely. So fire rating isn't really what you want it to be. From there, you get into rock wool. Rock wool is mineral fiber. It's non-combustible, phenomenal on fire performance, and could be a little bit better on R value. That's just me. But that's kind of what you're getting with it. It's not really why you're specifying. You're specifying for the fire performance. Which, by the way, mineral fiber currently specifying. A little bit, yeah, here and there when needed. Cool. All right, so from expanded, you graduate up to the extruded board, which is what you have in front of you. R10 at 2 inches, a little bit better on the fire, but it's really just a step up. And then you get into ISO, which is, again, just kind of a step up from there. R12 at 2 inches, a little bit better on the fire. All this look correct? Yes. Cool. All right, so that's pretty much everything that was in the market before Kingspan came into the game when they bought us a few years ago. Here is the new stuff. So this is Cooltherm. Cooltherm is the kind of chocolate-looking board in front of you. It is an R16 at 2 inches, and it has all the fire ratings. It has a fire rating performance on par with mineral fiber, and I'll show you that in a second. It is also on a closed cell system, so it doesn't have much or any moisture ingress. No water is going to get into it. It's not going to reduce the R value over an extended period of time. It comes in several different kinds of spacers, and it comes in several different kinds of applications, which we're going to cover. And then we're going to get into Optimar, which is the Klondike bar sitting right there. That has an R57 at 2 inches and is used primarily in commercial roofing. So based on this chart, has everybody kind of got a feel for what we're going to be talking about? All right, cool. All right, so let's talk Cooltherm a little bit. So Cooltherm's a board we introduced, I want to say 2 years ago, maybe this October, but one Kingspan's been using around the world for the last 30 years. So it's a phenolic insulation. It has very low global warming potential, no ozone depletion potential, so it's an environmentally friendly product. And it comes all kinds of thicknesses, and we're stocking several of them over at Winchester. For facers, you can see, I mean, you have foil facer both sides, you have fiberglass facer both sides, you have foil facer on one side, fiberglass facer on another side. So it really does mix it up, and it really helps kind of flex out the application you put it in. Kind of explain how it's made, almost like any other foam. You have a running track with whatever facers you're bonding it to on both sides of the track. You spread the mixture, it starts to expand, and then we take it, we put a pH neutralizer in it to help set the chemistry. We put it into a heating kiln, just kind of let everything set, start reaching the thickness, take it out, put it into another heating kiln just to make sure everything's set, and then we take it out of that, we cut it up, package it up, and send it out. Make sense? Oh, sweet. All right. So like I said, pretty solid on fire. So here we have, all right, so here you have expanded, polyiso, and then Cooltherm. And this is what happens when you take the torch to it. All right, so pretty much what you'd expect. It burns. There's flame spread, smoke development. You know, again, Class A, but bottom of the barrel. You get into ISO, which is a little bit up from that. So you're still seeing some smoke development, a little bit of flame spread, but not as bad. But keep in mind, guys, if a fire was to break out in your building, what you don't need to worry about is somebody burning to death. You need to worry about suffocating from the smoke. So the smoke development is what you need to be concerned the most with. And then when it comes to the cool therm product, no smoke, no flame development, it just chars over, which is ideally what you want. You know, I mean, ideally you don't want any damage, but if there was any damage to occur, you'd like for the board to take it all, not spread it up, not propagate, not disintegrate, and then add fuel to the fire as it moves its way around. Basically, it just contains it right on the board. If you were to take that piece and cut it out, you would see that the inside of the product is actually exactly the same. The fire is not penetrating through the product and disintegrating it on its way by. It's just burnt on the surface. So let's talk a little bit about application. Okay, so I'd just like to say basically anywhere you can put rigid insulation, you can put this except the roof. The density isn't quite what we need it to be. But you can use it up in a rain screen system. We are NFPA 285 approved. We have tested, I think we've done about a dozen systems yet, all kinds of exterior claddings. So we're on our way there, and we have more tests coming up. Oh, sweet. All right, has anyone ever seen a 285 test done? No? I really want to. It's really cool. So what they do is they basically build up the full system. Because remember, 285 doesn't just test for the fire performance of a single product, it tests for the entire system. So they build up the rain screen system, they put it in a wooden crate basically in this chimney, and then they light it up. So one of these is mineral fiber and one of these is phenol. Take a guess and, look and tell me if anybody can tell me which is which. Anybody? It's a 50-50 shot, guys. NJ4 is what? Sorry. I appreciate it, man. I appreciate it. Yeah, so the mineral wool's on top and the phenol is on the bottom. So just kind of taking a look, you can see that there's a little bit more of the flame spread up top, a little more contained. And then after, I think another minute or so, they're going to come put it out. And I want you to pay attention to the temperature and how quickly the cool therm cools down as opposed to the mineral fiber. See it dropping? So that's the difference. And it's kind of tough to see. But if you could, up top is where the mineral wool is. Honestly, it looks pretty good. It doesn't look like, it does what it did. It didn't combust. And the cool therm, admittedly, does look worse for wear. But again, I can tell you that it doesn't do a good job of showing it, but if you peeled it back, you could actually see behind it that the system's still fully protected. It's the board that takes the brunt of the damage without spreading the fire around to everything else. And that's really what's special about it. Okay, so cavity. So we, special shout out to Holly. We are partnering up with Glengarry Brick on a system that I think we're on the cusp of testing, so I can't tell you all that much about it. But we are working on a thin brick system with Glengarry for the cool therm material. Basically the idea, I'll actually skip to that. Framing, concrete sandwich, all that fun stuff. So actually we'll do that. Basically the idea, and we'll talk more about it in a second. The idea is that if you can thin out your wall system, then you can actually expand on a lot. You can help save the contractor money on through-wall flashing and fasteners. You can make the install easier. You can increase the actual footprint of living space without having to actually widen the building. You can help maintain property lines. You can do a lot with it. For the K10, this is one I like talking about because this is something we've actually been able to move a good amount of. Do you guys do any podium construction like that? Looks like a good bit of that. What are you guys using for the insulation on top of the parking garage? Spray foam, mineral fiber? All of it. Okay. All right, well, cool. So you're already familiar with the application. That's what I was getting at. So this is what's cool about the K10. So K10, because of its closed cell system and because of its fire performance, can actually be left exposed. So for anybody who hasn't worked on a project like this, what happens is when you do it, you have to insulate the top floor of the parking garage because that's the first floor of the living space. Basically, you have to seal the lid. So what you do is typically you spray foam it, or you can just stick up a bunch of batter mineral wool. Either way, it requires multiple trades coming back through, doing all the work, and it's a bit of a process, and the labor can actually end up adding up pretty good. With this, it's easy. All you have to do is take it, fix it up onto the roof deck, screw it in, take the seams, hang your mechanical fixings, wash your hands, you're done. So it's a much faster install. I think we've done product comparisons. Typically with K10, you're coming in at about 15 to 18% lower total install cost than using spray foam or a mineral. So it is a sleeker install. It is easier to put up, and pricing is not going to set you back all that much. So it's a product we're good with. We did do some of it in the area and on a school where they wanted to. It was a renovation for a Christian school, and they wanted to get an R39 for the roof, but they didn't want to have to go through and put in a new roof. So they took 2 layers of 60 millimeter, stuck it up onto the corrugated metal ceiling on the inside, put an acoustical ceiling over it, and they had an R39.5 at, I want to say it was under 4 3/4 inches, probably somewhere around 4.6 inches. All right, and that kind of gets into the usable space we talked about. Just to give you an idea, so basically it's double. Just think of it like that, because that's the problem. Is when you meet with contractors and you talk to them about this stuff, they want to do, board for board, thickness for thickness. What's 1 inch of cool therm compared to 1 inch of mineral fiber? And I would say we're a little bit above. But when you think of it in R value, so to get an R8 for cool therm, you need 2 inches of mineral fiber, and that's the way to think about it. So to reverse engineer that, you can actually go backwards. So you're basically cutting your wall in half and using it to honestly great advantage to everyone. Again, contractors have smaller fasteners, smaller through-wall flashing, easier to put up and work with. You can cut it, you can score it, you can do all the stuff with it. For you guys, not to say, as I understand, you guys have actually come high. You guys are very reputable in the field, by the way. I don't know if you know that. The contractors think extremely high of you, especially the masons. And so I know you probably wouldn't overlook a design like this, but you do have contemporaries who will specify an R21, but use a design from 5 years ago that only gives you 3 inches in the walls to do it. And then I'm getting a call from contractors saying, hey, how am I supposed to hit this R value when I don't have enough space to do it? And it's not every day, but it is often enough. And this is actually something the product would let you do. Instead of having to go back and completely do a full redesign on a wall system, you specify the board, you hit your R value, and you just keep on moving. So that's a benefit for you, and then for the owner, and just to kind of just run through the example. So imagine you took away 2 inches of space by specifying cool therm over mineral fiber, ISO, whatever you want. Say it was 60,000 square foot, 3-story building, pretty standard. By taking away those 2 inches, you actually give yourself about 300 additional square foot of space. We actually looked up the rent values for the market. Marcus and Bill chat, it's about $40. But just by taking away the 2 inches of space and giving it back onto the interior and letting your owner rent that out as leasable space, they're increasing the return on the investment by $11,000 in the first month, over $100,000 in the first year, and then by almost $700,000 in a 5-year period. And that's just not an example. That is very real money. That's very much something you can go and show to them. DC, we know if anybody lives down there, bless you, because it is crazy expensive. So there are very real dollars to be made. We did a job up in New York where we saved the guy like 3 inches on a high-rise apartment building. He ended up recouping his investment in like 7 months, and then after that, he was stacking almost $1 million in profit. It is a very, very real option you can go and show to your owners, to your customers, your clients. And it's not really going to charge them any extra money because on total install costs, we come out even or even a little bit lower. So we actually are the least expensive option, or the less expensive option. All right, and that's just kind of a graph of what we got. takeaway is that by using Cooltherm, you're basically cutting the thickness of everything in half, and it just makes it easier for everybody involved. Okay, and then that's our little hippopotamus. Big impact, small footprint. Yes. All right, what do you think? It's cool? Something you guys might use? Anybody have any ideas, questions? Come on, hit me. I'm on camera here, guys. Come on, gotta make me look good. All right, cool. All right, well, if anybody wants to talk about it a little bit more afterwards, feel free to come up, get at me. I love talking about it. All right, so let's get into Optimar. Who's got the Klondike bar? Right there. All right, so Optimar is cool. I like to tell people that if Stanley Kubrick got into designing building materials and not making films, that's the kind of stuff he'd be coming up with. How it's actually made, I can't tell you. It's like top secret. I don't think anybody on this side of the pond even knows. They keep it in like a locked up facility. It's great. But it is used for balcony terraces and commercial re-roof systems. I can show you what's on the inside. So it's like silica. It's like a greasy sand that they encase in a fabric, and then they put in foil, and then they suck the atmosphere out of it. And that's how it gets such a high R value. So to give you an idea, when it comes to products like these, they get their thermal efficiency by trapping thermally efficient blowing agents inside the cellular structure. All right, that's why it has high R value. Excuse me. With that, by taking the atmosphere out of it, you actually take it beyond like conduction and convection, and then all you have to worry about is radiation, which is why you wrap it in foil to help reflect that back out. So it ends up giving it, 5 times better. To talk a little application, what we've been doing with it, over in the UK, they use it for a lot of balconies and terraces. Over here, we've been pushing it more on the actual roofing side. So you can use it for your single ply, you can use it for your IRMA systems. On the single ply side, are you guys currently specifying a particular single ply manufacturer, like Carlisle or Henry or anybody like that? Okay, cool. So on this, we partnered up exclusively with Carlisle. We kind of went to them a few years ago, told them about it. They were interested, and they've really supported us since. So if you're going to use this, it would be the Carlisle system. If you're using an IRMA system, which is an inverted roofing membrane system, where you basically put the weather barrier down first, and then you put down all of your dimple drainage and rigid insulation. That's when you use the extruded board. All we have to use is ours, but it doesn't matter what manufacturer you go. All right, and that's just kind of an idea of the system build-up. So this is a single ply system. So you have your roof deck, and then you go down, you put down your dimple drainage mat, your Optimar, and then you put down some ISO because you want to sandwich it. Because if it hasn't occurred to anybody yet, it's vacuum insulated. So if you puncture it, all the air starts rushing in and all the R value starts to drop. So if you puncture it, you go from an R57 at 2 inches to basically an R10. And I know that sounds like it's destined to happen on a job site, but we do take several steps to make sure that the contractor's educated, to make sure they understand what they can and cannot do with it. And then we also take some other safety net measures as well. We'll talk about in a second. So this is kind of what the design would look like. Actually, I'll just talk about it right now. So it's a little involved, just to be completely honest with you. It's pretty much strictly for re-roof. If you were doing some kind of new construction, you had spacing limitation issues, but you still had to get an R value, maybe it could work. But really, it's on a re-roof system. And I'll talk about a job example in a little bit. But say you had a project like that where you wanted to use it. I would get the designs. We would give you a budget, approve the budget. We would talk about, hey, here's what we think we can get for R value. Typically, and because I'll just tell you, it's a minimum R value system. It's not an average R value system. I think I got that backwards. An average R value system, not a minimum R value system. Because you can't puncture it, you can't cut it, you can't flash it around things. So say you had a drain or you had some kind of railing that you had to go around, you would just have to stuff more single ply ISO or extruded polystyrene around it. So the R57 is not what you're getting on the roof. There's typically about 10 to 15% loss because you're having to fill it with other insulation. That's why we shoot for the higher R value so we can come back down. So ballpark, we usually get around an R38, 39 using this stuff. Up in New York, we're starting to push it a little bit more to the 40s, but that's just along with code. Anywho, we have a team over in Poland we send the designs to, and basically they just do this. They take the CAD drawing and they puzzle piece it together. And they say, hey, here's how much Optimar we're going to be able to get on this system. Here's how much fill you have to use. Go do it. So they basically just send us the puzzle piece, and then we have the guys go out and put it up. So it's pretty straightforward. Ah, sweet project example. All right, anybody been to New York? Right, everybody like New York? Yeah, it's cool. I just drove through it for the first time yesterday. But we did a project up there, I think it was last spring. That kind of looks like early spring. So we did an apartment complex over Fifth Ave, and the guy was quoted, the owner was quoted like, I think it's like $1.2 million to rip up the old roof, put a new one down, raise up the doorways, the parapets, the railings, all that, because he was going to have to put like 7 or 8 inches of insulation to meet code, and he had to clear out like the top 3 floors or top 3 units to get it done. So he was losing money on that. So overall, it was very expensive. We went in with Optimar and we got it done for like $70K. And it's what was going to be a 6 to 8 month project ended up being a week and a half, 2 weeks. So that's the application. Like that's what you got to think of for is, you know, putting in a new roof on a new construction building, probably not. Ripping up an old roof that has little to no insulation, especially what they have over in DC, how old those buildings are, that gets expensive. And then not only that, you're raising the roof entirely to where the building may not even look like the building before. With this, you can put it down, you can keep the profile thin, build up spine, you don't have to worry about vaulted ceilings underneath, or changing the entire look of the building. You can basically keep it exactly as is while still meeting current R value code, and you can save yourself a substantial amount of money doing so. Ah, sweet, there it is. All right, so basically everything green is where the Optimar panels went, and then everything gray was fill. We have these little polyiso infill strips that we put along the edge of the perimeter, and it just kind of frames the whole picture. All right, so there's that. So it was an urban system. So they put down their weather barrier, they put down their dimple drainage mat, they put the Optimar on top, and then they covered it with 60 PSI extruded board just to protect it, give it a little bit of additional R value. On that, it was 2 pieces of 1.5 inches. And then I think the whole system, I'm not entirely certain what the full buildup of the system was. I'll have to find out. But I do know we got them in R37, and they were just looking for the R30. So we actually set them up for the next, you know, call it 5 years before the codes change again. So that's basically the product line. So we have the vacuum insulated roofing board, we have the phenolic rigid cool therm board, and then we have the extruded polystyrene board. All right, if you're interested, we're on ARCAT, AC Daily, all those third-party libraries if you want to look this up for previous specs. And then just kind of the summary. I mean, I think it's pretty much obvious. Basically what we're trying to do, guys, is we're trying to help thin out the wall profile. We're trying to give you guys higher R-value solutions without having to make compromises anywhere. And we're really just trying to make it easier for everybody involved, you, contractor, and owner. All right. How was it? Did you learn anything?
Yeah.
Did you have fun? Okay. All right, I'll take that. All right, cool. Any questions? Yes, ma'am.
So if you use vacuum sealed panels on the roof, you're not to do any kind of mechanical vacuuming of your roof.
No, ma'am. The roof, I mean, yeah, through it. No. I mean, what you have, you can rely on the weight from the ballast of the pavers to hold it down. You can use adhesive, and then, so if you're using a single ply, yeah, you'd have to, no, you wouldn't be able to. It's going to puncture it, and then you just pay for very expensive extruder. Also keep in mind, if we were to do that and we were to send you the boards you needed to puzzle pieces together, we wouldn't just send you the perfect amount of boards so that it wouldn't cost you or SOL. We would send you multiple of each in case something happened, there were accidents. We do make the contractor sign. It's like 2 or 3 different pieces of paper acknowledging what the board is, how it works, and how not to pass through it. So we do take all the quality control measures we can, and guaranteed when I sell one, haven't yet, working on it, you will see me out there every day making sure it's being put down correctly. So we are very, very involved in it. So if, you know, again, something might go wrong, but we're going to make sure it doesn't. Any other questions? Thank you. Anybody? Come on, guys. I know I just blew your minds. All right, once you get over the shock, we can go back into it. All right, so that was a lot, and now we're going to do a short sprint. Cool. All right, so since we just kind of talked about all this, it's going to be mostly review, and we're just going to blow through. Does everybody have time? Sweet. All right, cool. All right, so this is our AI presentation, and we're just going to get into learning objectives. So we're going to talk about heat transfer methods. We're going to talk about different types of rigid insulation, their fitness for use, applications, and then fire performance. Okay. All right, so introduction, insulation. It's very important. And new residential audience. It does serve a very important purpose, and it actually has come a very long way, and that's kind of the heart of the presentation. So I hesitate to say back in the day because I wasn't there for back in the day. I don't feel like I've earned that yet. So several years ago, you really didn't have that much by way of options for insulation. It was either bulky thick foam or fiberglass bats. You either stuffed it with bats or you just tried to stick up as much foam as you could. No longer the case today. Again, I've spoken with a lot of contractors, and from what I'm told, like 2002, people would come and try to pitch you a product, and it wouldn't work. It wouldn't do what it said it was going to do. But that's not really much the case anymore. I think the science and the technology for the industry has really caught up, and it's not so much now that the product doesn't do what it says it does. It's about how much do you want to pay for it and how bad do you really need it. So that's kind of, which I mean, that's its own set of challenges, but it's good because that means you have options, and I'd always rather have the option. So basically, just really quickly how it works. Insulation, it keeps hot air from leaking out, it keeps cold weather from coming in. Fairly straightforward. Conduction, taking it back to third grade science, is basically the transfer of heat across space and gas, anything touching each other, or just where it can get to. Something to keep in mind is that whenever something has a low thermal conductivity value, it means it actually has high thermal performance. So it's inverted. So just keep that. Convection, basically just going right through the gas. And then when you get into radiation, a little bit tougher because radiation goes across space, gas, solids, everything. So the best way to combat that is with a foil facer. All right, so measuring insulation performance. All right, so you have your lambda, K value, which is basically the metric version of R value. The lower your K value, the higher your insulation. Likewise, with R value, as everybody should know, the higher your R value, the higher your insulation, right? Makes sense? Cool. And then you have your U value, which is like the K value in that you want a low U value for a higher thermal efficiency, but the difference for that is the U value actually measures the full system. So K and R values just measure specific products, and the U value actually measures the full, imagine a built-up roofing system. The R value is the full system. Okay. Something to watch out for is thermal bridging. Kind of tough to mitigate, to be completely honest, because you're going to get thermal bridging through the studs, because wood and steel aren't that thermally efficient, if at all. And then you have non-repeating thermal bridging, which is where it's coming in through maybe like a fastener hole. And then you have the geometric, which occurs at the transitions from ceiling to wall and wall to floor. Airtightness. So airtightness is tough. Like if you're putting expanded polystyrene up on a wall, it's open cell. It has gas in the cellular structure, so air and moisture will be able to penetrate through that and get through. And then you also, and then if the air pressure actually on the inside of the building is enough, it can actually start ripping it through pretty extensively. So then you get humid, dry air, it's not performing up to the thermal efficiency bar, your air conditioning unit's working a lot harder, it's kind of a mess. And then you have convective bypass, which is when you use, say, a closed cell system, there's no gas in the cellular structure, so it can't get through the board, so it has to go around it. Really, the best way to mitigate that is just best practice installation techniques, sealing seams, making sure you cap everything off, stuff like that. Oh, God, I hate this slide. I'm sorry to show this to you after you've just eaten. So moisture and condensation, it's a total pain. I originally come from Florida, and just the amount of moisture damage I've seen on, single-family homes, ridiculous. So two things to watch out for is condensation, obviously. So there's the surface, which is, if there was water on the wall, there was a problem. But interstitial stuff, because it's actually on the inside, so it's in the interior in between, and you can't see it, obviously. So, and you don't really know it until it's already too late. It looks like that. So, effective moisture control. Ventilation system, probably the best way to do it. But those can be expensive, tough to put up, and expensive when you have to replace them every dozen years. Personal favorite is the drainage barrier on the wall. There are companies that have drainage house wraps or like a drainage plane foam barrier you can put up that's not going to take on the water and will help wick it out of the system. My whole thing is that why even let the water get in the first place if you can just make sure it doesn't and keep it out. So that's why I'm partial to the drainage. Okay, let's talk about rigid. All right, so this is again more of a review. So you have expanded polystyrene. It's an open cell foam. It's got an R value of 4 per inch, and it will take on some water over a period of time, and that will drive down the thermal efficiency of the board. Expanded extruded polystyrene, basically just the bigger, better version of that. Closed cell, better R value. You know, I've had people who've told me they dug up extruded polystyrene from like 25 years ago, and it's got some water in it. Totally believe it. But on the long term, or at the very least when you would be going about replacing it, it'll hold up just fine. For your ISO, again, same thing, just a little bit better on R value, a little bit better on qualifications. Although I do believe it does take, it takes on a little bit, for sure. And then phenolic. Although fun fact about ISO, one of the leading extruded manufacturers did a study on it and saw that actually as it gets colder in temperature, polyiso actually becomes less and less thermally efficient, almost by like 60%, something ridiculous. So that was a fun fact I just recently learned about. And then there's the phenolic foam, relatively new player to the market. You get all the fun of extruded polystyrene with all the fun of mineral fiber. Just think of it like this. If extruded polystyrene and mineral fiber had a kid, that's how you get phenolic. That's a gross oversimplification, but it's the best way to think about it. Then you get into your mineral wool, phenomenal on fire rating, non-combustible, 285 exempt. That's awesome. And then you get your R4 per inch, and then vacuum insulated panels, pretty much used exclusively in roofing with the R20 foam. Okay. All right, so you've heard me say it a few times, but this is basically what it looks like. So that is what the cellular structure of expanded polystyrene looks like, and then you have your extruded polystyrene on the left. So, talk about this. All right, cool. All right, so let's talk a little bit about application. So on roofing, you're looking on, at least in the system, you're looking at extruded polystyrene for the inverted roofing membrane assembly, and then vacuum insulated panels when you need to save some space. On the single ply, you're looking at polyisocyanogen or also a vacuum insulated panel coupled with it. For the walls, phenolic, XPS, ISO, and mineral fiber when 285 approval is crucial and you have enough thickness to play with. Structural soffit ceiling, pretty much the same thing. Phenolic, mineral wool, spray foam, probably mostly spray foam. The interior walls, phenolic and XPS, and then below grade, XPS almost always, just kind of as a rule of thumb, but you do see expanded sometimes. We bid, or a certain company, I don't think I can say who, bid a job for a hospital and it had this huge lawn out front. And instead of digging up all the dirt and moving it, because it's heavy and expensive, they just made like these giant tofu block size of expanded foam, put them in the dirt, put them in the ground, threw some dirt on top of it, called it a day. So when you're using it not for any kind of particular R value, you're just using it for fill, that's where you would see expanded polystyrene and below grade applications. Okay, fire performance. So ASTM E84, if you're not familiar, it just basically certifies you for Class A, B, C fire rating. And then NFPA 285, which everybody knows about, is just a full-scale fire test for a complete system buildup. So here's how everybody does. So expanded polystyrene passes under EPIS. XPS passes when it's coupled with non-combustible claddings like brick. And then you have phenolic foam, which is passed about a dozen, and it's looking to pass even more. You have your ISO, which some, and then your mineral fiber, which is exempt because it's not combustible. Then you get into your vacuum insulated panel or board, which you don't need to do a 285 on, it's a roofing board. Okay. And this is kind of cool. Again, I can't really speak or attest to the kind of testing that was being done on insulation 15, 20 years ago, but I would imagine it probably wasn't as extensive. And that's just, and to be completely honest with you guys, I couldn't tell you what really any of these tests test for. But it is worth knowing that it is very rigorous, and if they are out there, they are making sure it's going to do exactly what you need it to do, so there isn't a failure, because, I mean, what's the point in upping the ante on the energy codes if none of it works in the first place, you know what I mean? All right, so let's talk case studies. Any soccer fans? Got one. Over at the Arsenal Stadium, they had done a little bit of renovation, and you can see kind of at the very bottom, like right there, that's actually not habitable space. It's where they keep storage and all things like that. So they had to go about re-insulating it. So they took the phenolic board and they stuck it over the top. So imagine that was your parking garage, that they insulated the bottom of the living space, which is right there. So that was a project they did a little while back. Down in North Carolina, they did a new build on a veterinary medicine, and they used the extruded board just because it was a better R value. They were worried about moisture penetration, all that stuff, so they didn't feel comfortable going with the expanded. And then the Geelong Library, which is in Australia. Anybody been to Australia? No? Not yet. There you go. That is the right answer. So this is the Geelong Library, and they actually use the phenolic foam on it for the spandrels so that they can kind of just get a little bit more flexible on the design. As you can see, it's really, really cool. All right, and that's the conclusion. But yeah, going back to this real quick. Just so you guys know, I never once in my life considered being an architect. Hands down, the worst present I ever got for Christmas was Legos. It's never appealed to me. But having worked in the industry for a few years and met with several people like yourselves, I definitely, if I was going to, I would want to do it because I want to design something cool. You know what I'm saying? Like I want to put something on a skyline that I can point to and be like, yo, I did that. That's me leaving a mark. And the more and more I've tried to talk to people about that, the more and more they just keep telling me that codes don't allow it. It doesn't lend itself to that. Like you have to get the job done how you can, not the way you want to do it. And that was super disappointing to hear. So that's why I dig on our products a lot, is because they can help you thin it out. They can give you a little bit of added flexibility. They can help you design and do really, really cool things without having to sacrifice not meeting code and getting the owner what they need and the residents or whoever's going to be living in their needs. So that's something to consider. I mean, just going forward, is that you don't have to do it the way everybody else is doing it. There are other options out there. And I mean, that's why we come here and talk to you. That's why they make you sit through these things, not just for the lunch, but so that you do know what's on the cutting edge, you do know what's coming, you do know what other people are using, so that you guys can actually go out and design and build a lot better for us. Because to be honest, guys, it starts with you, and we need you guys to be as involved and as knowledgeable as possible. All right, that's all I have. Cool. All right, any questions?
Any questions about this?
You talked about today's sustainability.
I can, Brian, if you want, I can get you I'll get you a full list of what we passed for 285. I can send that to you. Don't know. I think we had looked at updating it into the brochure, but we looked at doing it and then we passed another, so then we had to go back and do it again and we just kept passing another. So I think they're waiting until we kind of hit a little bit of a cool down. I think we have 2 or 3 more tests coming up over the next couple months. So after that, we should do it. But I'll see what I can find and I'll send it to you. And for sure, I will. If it's cool with you guys, I'll follow up with Ms. Kendall, and then I will just kind of put in some cliff notes about what we talked about today, the benefit, where to use it, and I'll put a link to the website, to those products on the website page right next to that, so you can just click and then just go check it out. But if anyone wants a card, if anyone wants to talk to me about anything, I will be here cleaning up. So feel free to come up and say hello. Cool?
Thank you.
All right, no worries. Thanks, guys. Thank you for coming. Thank you, everyone in Charlottesville. And was it Vienna? Tyson's. Thank you. Love Tyson's. Great Uniqlo over there.